Okay, so for question 3, we have here that an 8 gram bullet is shot into a 4 kilogram block at rest on a frictionless horizontal surface. The bullet remains lodged in the block. The block moves into an ideal massless spring and compresses by 8.7 centimeters. The spring constant of the spring is 2,400 newtons per meter. The initial velocity of the bullet is closest to, so it's asking us to find the initial velocity of the bullet. So first off, let's set up the equation to see what we need to, how to use what we have to find the initial velocity. Okay, so it's important to note that m times the velocity is going to be equal to, times the initial velocity is going to be equal to the mass of the bullet plus the mass of the block times the final velocity, right? And to find the initial velocity, we have basically this equation right here. The initial velocity is equal to m plus the other mass divided by m times the final velocity. And we have here also some conservations of kinetic energy and potential energy, right? And we use those as well. We can get that, right, by solving for v of x squared. We start getting this, and we get, this is another way of defining v final, right? So v initial, we can find it by doing this, right? And then we know that the v of f is also equal to this square root of x, the square root of k, which is the spring constant, divide per minute of the distance, right? So basically what we end up is with this. The v initial is going to be equal to it's going to be equal to m, all this times the square root of k, and that should give us the answer. Once you plug in everything in that's given in the problem, it should be around 1066. So the answer should be around C. Yeah, it should be C. And that's it.